Hello, my dear students. So, today in this chemistry class, I'm going to tell the new chapter called as solutions. Right? So, this is one of the physical chemistry chapter, right? So, this is also an important chapter. So, in this physical chemistry chapter, from your exam point of view, you'll be having 7 marks, and you'll be having three questions. That is question number one, question number 2, and question number 28. So as you know that question number 1 carries 1 marks, question number 2 also carries 1 marks, and question number 28 carries 5 marks. So totally that will be equal to 7 marks from this chapter. So question number 28 will be having sub questions, right? So one poem will be there, as well as some of the laws or some of the definitions will be asked. Depends. We'll study one of the we'll study different types of concepts in this. Now, this is with respect to the questions asked in the examination. So total there will be 7 marks allotted for this chapter. Now, in this chapter, we are going to study the definition of solution. I think you might be knowing from your high school, you know what is meant by solution, but here we are going to study in details, right? So, what are the different components of solution, right? Types of solution, which are the different methods of concentration of solution, or how we are going to measure the solutions, and also different types of laws are there, right? Their applications and qualitative properties, and mainly the problems. Okay, so basically, I will begin this chapter by the definition, right? So I think you may answer with respect to the definition of solution. So solutions is nothing but uh, homogeneous. It is a homogeneous mixture. It is a homogeneous mixture of two pure. It is a homogeneous mixture of two pure components. So I think you may understand, right? So it is a homogeneous mixture of two pure components. So here homo refers to similar, right? So either it may be a solid, liquid, or gas, or vice versa, depend upon the type of solution. So here solution mainly consists of two pure components. Now, if the solution consists of two pure components, then that solution we call it as a binary solution. We call it as what? A binary solution. As the name indicates, binary. So here bi refers to two. So two components are present, so hence it is called as binary. Now, depending upon the number of solute and solvent particles, either it may be an tertiary also or quaternary also, but for your syllabus we have binary solutions. So definition of solution, once again I will repeat, it is a homogeneous mixture of two pure components, right? If it is two pure components, we call that solution as what? A binary solution. Now, what are the different components of solution? What are the different components or basic substance which are present in a solution? So I think you may know the answer. So solution basically consists of a solute as well as a solvent. Basically consists of what? A solute and solvent. This together it forms what? Solution. It together forms what? A solution. So solution basically consists of solute and solvent. Now you may ask, what do you mean by a solute, right? Or what is definition of a solute? Now there are two different definitions, right? So I will discuss one by one. So first definition of solute is the substance, the substance which gets dissolved, which gets, I think G is missing. Okay, which gets dissolved, which gets dissolved in a solution, in a solution. it is said to be as what? The solute. So I repeat once again, solute can be defined as, the first way of definition of solute is, it is a substance which gets dissolved in a solution. Or there is one more way of defining of solute, that is the substance which is present, the substance which is present in less less amount in a solution, in a solution. So there are two definitions which are you feel easy. So you can go with respect to, I think there's a less LESS, right? LESS. So less amount of solution. Okay. So there are two definitions. So one is the substance which gets dissolved in a solution, or the substance which is present in less amount in a solution. Now, these are the definition I think you can understand. So if I take a solution, you know that solution consists of two components, one is solute and solvent. In that solution, the substance which is lesser amount, it is said to be a solute. I'll give the example. Right before that, I'll go for the definition of solvent also. So solvent can be defined in also two ways. So first way is the substance, the substance, the substance is a substance which dissolves here. It is a little bit quite different. In solute, it gets dissolved, but in solvent, it dissolves. Solute. It dissolves what? Solute. So that substance we say it as what? Solvent. So solvent is defined as what? The substance which dissolves a solute in a solution is called solvent. Now, what is the second way of definition? So we said in solute that the second definition is what? It is present in less amount. In case of solvent, it is present. It is present in large. It is present in large amount in a solution. That substance we call it as what? Solvent. So solvent can be defined as what? The substance which dissolves solute in a solution is called a solvent, or the substance which is present in large amount is also said to be in a large amount in a solution is called as solvent. Now you may ask one of the example for this, right? Now say for example I have 2 gram of sugar in 100 ml of water. 2 gram of sugar in 100 ml of water. So I think you can recognize easily in this solution. So we call this one as basically as what? Sugar. We call this basically as what? A sugar solution, right? So in this sugar solution, uh, in this sugar solution, so the quantity which is present here in lesser amount is your, so it is lesser amount here is sugar, so hence sugar is said to be as what? The solute, and the water is said to be as what? A solvent, right? So different example we can see, right? Now coming for uh, the next concept called as types of solution. Next concept we call it as what? uh, Types of solution. So this is also very important one. This is very important one. Now, what do you mean by types of solution? Here, in this types of solution, before I discuss, we know that matter exists in three forms. That is a solid, liquid, or gas. Now, the solute and solvent may be either solid, liquid, or gas, or vice versa. You know what you mean by vice versa? That is, if solute is a gas, it may also be a solvent. If solid is a solvent, maybe also be solute. So, like this, totally there are 9 types of solution. There are how many? 9 types of solutions. So, we are going to discuss here one by one, right? So before I explain here, I'm going to take you directly to the tabular column where we can see the different types of solution, right? So I go here with respect to the different types of solution. So here you can see, right, the types of solution we, as I told, either it may be a gaseous solution, or it may be liquid solution, or it may be a solid solution. So here the solute here may be either gas, liquid, or solid. But the solvent here is fixed. You can see here all the solvents are gaseous. Similarly, liquid solution, if I take types of solution as liquid solution, here you can see the solutes are changed as like the gaseous solution, gas, liquid, or solid. But here solvent fixed here is liquid. Similarly, here also, so in solid solution, the solvent here are solid. Now this is important from your exam point of view for 1 marks also. They may give you the solute and solvent. They may ask you for example. So we'll discuss one by one. If the solute is gas and solvent, as we know that is a gaseous solution, it is fixed. So the example commonly for here, the gaseous solution of gas in gas. We say it as gas in gas. That is, gas is solute and solvent is also a gas. So the example here is mixture of oxygen and nitrogen gas. So here you can see, you know that oxygen is also a gas and nitrogen is also a gas. So hence it is an example for gas in gas solution. Similarly, if I want to take the solute as liquid and solvent as gas, you can see the example of chloroform mixed with nitrogen gas. So chloroform is a liquid, whereas nitrogen gas is a gas. So I think you know the formula of chloroform. That is what is the formula of chloroform? Anyone can answer the formula of the chloroform. What is the formula? So it is CHCl. So I think you know where we use this chloroform, right? So it is basically used for the anesthesia and during the operations, or it may be seen in some of the films, right? So it is commonly used for kidnapping, right? So making unconsciousness, right? So that is one of the concept we were discussing with respect to uh, the example, right? So we have seen the liquid in gas. Similarly, for solid in gas, the example here for this is camphor in nitrogen gas. So here you can easily remember in solvent when I take all their three are gases. So here the gases are nitrogen. Only we are going to change is the solute, gas, liquid, and solid. So here for solid solute, the camphor, we know that it is a karpura, we commonly say in Canada. So that is the example for solid state. When it is taken in nitrogen gas, it becomes the example for solid in gas. So these are all the examples which involve for gaseous solution. Now similarly, we go for the next one called as liquid solutions. So here also you can see some of the examples for the solvent here is fixed, that is liquid. We are going to change the solute as gas, liquid, and solid. So example for gas and liquid is oxygen dissolved in water, whereas example for liquid in liquid is ethanol dissolved in water. You know this example easily, right? So whereas example for solid in liquid is glucose in water, so or sugar solution or salt solution, any example, right? So as I discussed earlier. Now coming for the last type of solution, that is where the solvent is solid, but we are going to change gas, liquid, solid as solute. So in gas in solid, the example is solution of hydrogen in palladium. So hydrogen is a gas, palladium is a solid. So example for gas in solid. So liquid in solid, so amalgam of mercury with sodium. So we commonly say it as a sodium amalgam, right? Now, similarly, the last one, solid in solid, copper dissolved in gold. So we know that it becomes a 22 karat gold, right? So gold usually of two types, that is 24 and 22. 24 is pure type of gold, whereas 22 karat is mixed with copper. So hence the example for solid in solid is copper dissolved in gold. So hence we can see here totally there are how many types of solutions possible? There are totally 9 types of solutions possible. Now we go for the next concept, right? So that is a very important one, right? So what is the concept is called as a concentration concentration of solutions. Concentration of solution. Now you may ask, what do you mean by concentration? Now, or what do you mean by concentration of solutions? Now, concentration of solutions is nothing but it is the amount of solute. It is the amount of solute which is present in given quantity, given quantity of solvent. So I think you can understand. So I okay. So amount of solute present in given quantity of solvent. So I think spelling mistake. So it is amount given quantity. So given. So we can define here the concentration of solution as what? Amount of solute present in given quantity of solvent. That means what? Now, as I gave an example there in a previous while defining the sugar solution, right? That is with respect to the 2 gram of that is so 2 gram of sugar in 100 ml of water. So here you can see we say commonly this one as a sugar solution, which defines the amount of solute as well as solvent. So according to the definition of concentration of solution, it is amount of solute. So here amount of solute is 2 gram. It is present in given quantity. So here the given quantity is how much? 100 ml of water. So the concentration of solution is defined as amount of solute present in given quantity of solution. So here we know what is the amount of sugar which is present in how much quantity of water. So if you know that amount of solute, how much it is present in the solvent, then we call it as what? Concentration of solution. So I think you can understand. You have understood the definition of concentration of solution. It is simple one. That is the amount of solute which is present in the known quantity of solvent. So that we call it as what? Concentration of solution. Say for example, I can give a simple example. Like say for example in your examination for chemistry, out of 100, out of 100, you have scored 70. So 70 out of 100. So you know that here 70 is the marks which you obtain and 100 is the total marks. So here out of 100 you have got 70. So in 100 ml, what is the quantity of sugar present? 2 gram. So like this, if we know what is the quantity of solute present in the solvent, then we say it as what? Concentration of solution. So this example makes you clear with respect to the what you mean by concentration of solution. So now we go for, there are different types of measurement of concentration of solution. So first one we go with respect to mass percentage. The first method is called as what? Mass percentage. So what do you mean by mass? So mass is always measured in gram or weight by weight. We can say it as weight by weight. So usually we write as W by W. So how can I define a mass percentage? So for this, I will go for one of the example, right? So here you can see the different concentration of solution, right? So percentage by mass, or we say it as a mass percentage. So here the definition of mass percentage is it is a ratio of mass of solute divided by mass of solution. So we know that percentage is always given in 100, right? So in we are multiplying by 100. So mass percentage or percentage by mass can be defined as what? The ratio of mass of solute presenting mass of solution. So here students should please remember solution. Here it is a mixture of solute and solvent. So hence sometimes they may give in the problem the solvent. So at that time you should not add directly the value of solvent. You should add the solute and solvent. So we are going to solve some problems, right? So you will understand, right? So here I will define once again percentage by mass, that is the ratio of mass of solute to the mass of solution into 100. So that will give you what? The mass percentage, or we say it as percentage by mass. Now, so we'll go here. So we'll solve some of the problems with respect to the mass percentage, right? So you can solve this example. So say for example, if 2 gram, if say for example 2 gram of ACl is present or dissolved. ACl is dissolved in 58 gram of water. 58 gram of water. What is the mass percentage? 2 gram of potassium chloride is dissolved in 50 gram of water. What is its mass percentage? I think you can solve this one. So what is the formula need to be applied for this? Is so formula is what? Mass of solute divided by mass of solution into 100. So you are solving, I suppose, right? So I'll also solve simultaneously. So mass percentage. So here mass percentage equal to, so mass percentage equal to, so mass of solute. So here mass of solute is how much? 2 grams divided by, now you tell me the formula, according to formula it is mass of solution, but in the question it is given as 58 grams of water. So it is not a solution, it is a solvent. So hence for solution what we need here is solute plus solvent, that is, so solute is 2 and the solvent is 58. So that is equal to how much? 60. That is equal to 60, right? So here we will take 2 divided by 60. So that will be equal to how much? And also you have to multiply this by, you have to multiply this by 100. So that will be equal to, you can calculate. So I'm also calculating. So nearly it is equal to 3.33 percentage, right? So what is the mass percentage of 2 gram of KCl dissolved in 50 gram of water? It is 3.33 percentage. So similarly, I can give you some one homework, right? So you can solve this one, right? So take this one as a homework, right? Or solve this one, right? So if 12 grams of 12 grams of NaCl, if 12 grams of NaCl is dissolved in 95 ml of 95 95 gram of water, what is its mass percentage? So you can take here this one as homework. So if you have any doubts you can later on message me, or I think it is an easy one, right? They have given the quantity of solute, they have given the quantity of solvent, apply this formula to get the answer, right? Okay, so this is the first method of calculation of concentration. We are going to measure the concentration, right? Now the next method we are going to study here is a volume. The second one, that is mass percentage finished. Second one is volume percentage. The second one here is, second one we are going to study here is volume percentage. For this volume percentage, everything is similar, but here volume is always expressed in is always expressed in ml, right? So we say it as v by v. We say it as v by v. So for mass we are taken as w by w, and for volume we are going to take volume by volume. So what is the formula here? It is same as that of mass percentage, but it is, since we are going to take measure the volume, so here instead of mass of solute we are going to take volume of solute, volume of solute divided by volume of volume of solvent, sorry, volume of solution, volume of solution into 100, right? So into volume of solution into 100. So formula is clear, I suppose, right? So everything is same except we are going to take instead of mass of solute, volume of solute, mass of solution instead of that, volume of solution into 100, right? So we're going to solve one of the example. I think you can directly solve. So the example for this one is say for example 33 ml of ethanol, 33 ml of ethanol is dissolved in 127 ml of 127 ml of solution, right? So I think you can see clearly here. I think 33 ml of ethanol is dissolved. I think 33 ml of ethanol is dissolved in 127 ml of solution, right? So what is its volume percentage, right? So you can solve this example, be a little bit clear or be careful. Why? Because here we have not solvent, we have solution. So what is the answer for this, right? I think you have solved or you are going to still solve, right? So here solute is ethanol because it is lesser amount, and solvent is a solution. They are given 120 ml of solution, so directly you can apply the formula. So what is the formula, right? So formula is volume of solute. So volume of solution solute is 33 ml. So volume of solution. Now here they are given directly what is the volume of solution. So directly take that one, that is 127 into 100. That will be equal to how much? 25.9 percentage, right? So so the volume percentage is equal to 25.9 percentage. So please do not forget to put the unit, that is percentage, since we are calculating in percentage, one percentage, right? Okay, then we go for the third type of concentration of solution. We are seeing here mass percentage, volume percentage. Now we will take mass and volume together, that is mass by volume, mass by volume percentage, right? So the next third type is mass by volume percentage. So you can see mass is given in weight W divided by volume is given by V, so that is equal to W by V, right? So how can you define mass by volume percentage? Now in earlier cases we are, there was directly mass and volume. Now we are taking mass by volume. So the formula for this one is mass is given as is a ratio of mass of solute divided by volume of solution. It is ratio of mass of solute to volume of solution into 100, right? So always remember into 100, right? So the third type is mass of solute divided by volume of solution into 100. So I think you can solve this example easily because we have solved earlier the three types of examples, right? So I will do directly the example. You can take it down. If so, here just a minute. We are going to take. right? So here we are going to solve the example. Say for example, if, okay, so if, if 14, if 14 gram of K2SO4 is, if 14 gram of K2SO4 is dissolved in, okay, if 14 gram of K2SO4 is dissolved in 75 ml of water, then what is its mass by volume percentage? So you can take this example. If 14 gram of K2SO4, that is potassium sulfate, is dissolved in 75 ml of water, what will be its mass by volume percentage? So you should remember the formula you can see here. If you want, mass by volume percentage is given by mass of solute divided by volume of solution into 100. So here you can substitute the values and you can solve the question as a homework. Okay, now we'll go for the next concept, right? So the next type of examples, right? So here one by one we are going to say, right? Okay, the next one is the type of concentration of solution we are going to discuss is molarity. So here you can see the term called as molarity. Here you can see the definition. Molarity tells the number of moles of solute in exactly 1 liter of solution. So you should see here, it is very important one, 1 liter of solution. Now, always the quantity may be given in liters. Also, we know that we can measure instead of liter in milliliter also. So there are two formulas. I'm going to tell both the formulas, right? So for timing, remember the main definition of this molarity as it is the ratio of moles of solute present in 1 liter of solution, right? Molarity is spelled with R and is represented by a capital M. So also you should remember the symbol for molarity is capital M. Now we need two pieces of information to calculate the molarity of a solute in a solution. That is, what is the mole of solute present in the solution, the volume of solution in liters containing the solute. So if we have these two quantities, then we can directly calculate what is the molarity of solution. So we'll go directly with respect to this example. So here for molarity of solution, so as we are discussing molarity, right? So in this molarity, so we have seen the formula. What is the formula? It is the moles of solute is a ratio of moles of solute which is present in 1 liter of solution, right? So 1 liter of solution. So moles of solute is amount of solute, right? So you have to calculate here by 1 liter of solution. So we can solve an example regarding the molarity, right? So say for example 600 grams of water, 600 grams of water is 600 grams of water is, or water, or we say it as a 600 gram of water. Okay, we'll go for one more example, uh, right? So say for example 5.5 grams, 5.5 grams of glucose. 5.5 grams of glucose. Say for example, glucose was dissolved in in 5 liter of solution. So I repeat once again question. So 5.5 gram of glucose was dissolved in 5 liter of solution. So what is its molarity, right? So how to calculate, right? So we know that molarity is given by the symbol M, that is equal to what is the moles of solute present? 5.5 divided by. Now already they have given the quantity in liters only, so we no need to very much, right? So that is directly substituted as a 5. So that will be equal to. So what are the different answers which I can get for this? So this is the easy one. So directly 5.5 you have to divide by 5. That is nearly equal to 1.1 polarity, right? So that is means what? So if I dissolve 5.5 grams of glucose in 5 liter of solution, the molarity of the solution will be 1.1. Now it is also, as I discussed earlier, that if the solution of molarity or grams and molarity is not given in liters, in term it is given in, say for example, if I take the same example, right? So if I take the same example, that is here I given 5 liters. So instead of 5 liters, I'll take it as 850 ml of solution, right? 850 ml of solution. At that time, how to calculate? I cannot apply this formula because here it is not given in terms of the liters, here it is given in terms of milliliters. So for that, there is a formula, that is the given mass of solute, that is you have to go for the same formula, that is molarity is equal to mass of solute divided by molar mass, molar mass of solute, molar mass of solute. This is whole divided by, remember student, don't confuse, I am taking the numerator as what? The given mass of solute divided by molar mass of solute, whole divided by volume of volume of solution in milliliter divided by 1000. So I think you can see here the definition. So I'll make this one a little bit clear, right? So the formula is mass of molarity is equal to mass of solute divided by molar mass of solute whole divided by volume of solution in ml divided by 1000. So when I apply this formula to the above solution or above problem, so what will be the formula? So the above formula will be molarity is equal to, so mass of solute given is 5.5, 5.5 divided by molar mass of solute. So which is the solute here? Glucose. So I think you can calculate a molecular mass of glucose. So molecular mass of glucose is nearly equal to how much? 180, right? This is whole divided by, right? Whole divided by. What is the volume of solution in ml? That is 850 ml of solution. This is divided by 1000. So when you simplify this, that will be equal to what? Or I will make simplify for you easily. 5.5. We are multiplying it by 1000 because this numerator denominator will come into numerator. Whole divided by 180 into 180 into 850, right? So when you solve this problem, so what is the answer for this? What is the molarity we get, right? So I think you understood this. This is the whole divided by this denominator goes to the numerator, right? So we are multiplied 5.5 into 1000 whole divided by 180 into 850. So when you simplify this, the answer will be nearly equal to how much? 0.035. Yeah, right. So the answer is how much? 0.035. Yeah. Now I think you understood with respect to the concept of molarity. I just glance with respect to the concept. This is very important one. That is, molarity is defined in two ways depending upon whether the quantity is given in liter or milliliter. So simply when we define, molarity is equal to moles of solute present in 1 liter of solution. If they give the quantity in liter, directly apply this formula. If they give in terms of milliliter, then molarity is equal to mass of solute divided by molar mass of solute whole divided by volume of solution in milliliter divided by 1000. So I'll give one of the problem as homework for you, right? So I'll take one of the example. If say just a minute. Okay, okay. So here we go. The problem is here. The problem is I'll go directly to the problem. So we from here only. Okay. If 70 gram of aluminium sulfate, if 17 grams of aluminum sulfate is is dissolved is dissolved in 680 ml. Sorry, okay, 680 ml of water. What is its molarity? So I repeat once again, you can just see the question. If 17 gram of aluminum sulfate is dissolved in 680 ml of water, what is its molarity? So you can solve this one and message me regarding the answer, right? Okay. So the next type of concentration of solution we are going to study here is I think this is the fourth type of concentration of solution. So this is the fourth type of concentration of solution, that is molality. So just students, so you just concentrate. So the fourth type here is uh, okay. The next concept we are going to study here is the molality. So here for molality, it is slightly different from that of molarity. That is, in case of CP students, see the differences. Molarity here is expressed in terms of, the spelling here is used as R, but here it is molality, LITY. So here you should be careful with respect to this. So here you can see molality. Here the molality is tells about the moles of solute dissolved in 1 kg. So this is important one students. You should see here the difference between the molarity and molarity. In terms of molarity, you can see it is present in 1 liter of solution, but in molality, it is in terms of 1 kg of solvent, right? So don't confuse. So molality is what? It is the ratio of moles of solute present in 1 kg of solvent. Now, in case of molarity, we use the symbol capital M, but in terms of molarity, we are going to use the symbol as a small letter m. So don't confuse and write this symbol for molarity, and don't confuse this symbol and write for molarity. So molarity is given by capital M, and molarity is given by small letter m. So here, unlike molarity, it is in liters, whereas molarity is in terms of kilograms, right? So as we have seen the problems in case of molarity, it may be in milliliter. Here also, the kilograms may be also expressed in terms of grams. So the problems are same, but only the difference is with respect to liters in case of molarity and kilograms in case of molality, right? So we go for the concept here. So molarity, right? So the concept of molality. So molality. So what is the symbol for molality? It is a small m. So you know the formula, that is the mass of solute by volume of solution in kilograms, right? So for molarity it is liters, for molarity it is kilograms. So I'll directly go for the problem. So the problem related to this, say for example, is 4.75 grams of solute or MgCl2 is dissolved in 440 grams of water, right? So I write as 4.75 grams of MgCl2 was dissolved in how much? 440 grams. So students, here it is not in terms of kilograms, it is grams. 440 grams of 440 grams of water. What is molality? What is its molality? So this is the question for you. Right? So what is its molality? So I think you can solve directly the answer for this. Everything is same, right? So you can write the formula here. So m. So what is the formula here? M. M is equal to, so here the what is the quantity of given quantity, right? So just a minute, right? So what is m? So here m is equal to, right? So as I told in the formula, it is a amount of solute. So amount of solute is 4.75 grams of MgCl2. Now students, remember magnesium chloride. What is the molecular mass? Can you calculate? Magnesium atomic mass is 24 and chlorine is 35.5. So there are two chlorine atoms, so that is 35.5 into 2. So when you calculate the molar mass of the MgCl2 will be equal to 95, right? This is whole divided by. So what is the next formula? Volume of solvent in gram. So that is how much? 440. This is whole divided by 1000. So when you simplify, so how do you simplify? It is 4.75. This 1000 will come into numerator. That is into 1000. divided by 440 into 95. So simplify this one. Give the answer. Right, you can solve this one. This is very easy. Right, that will be equal to 0.1. So that will be equal to 0.11. Yeah, right. So this is the simple one. Right, so based upon, say for example, instead of in the above formula, if they give directly kilograms, right, so 440 grams, instead of that if they give 4 kgs of water directly, instead of that you can substitute this whole divided by 4.75 divided by directly 4 kgs of water. So simplify it, you get the answer. So I think you understood the concept of molarity and molarity. So difference between molarity and molarity is what? Molarity is always written by the symbol or represented by symbol capital M. Molarity is represented by the symbol small m. Molarity, the formula for molarity is what? The mass of solute representing 1 liter of solution, whereas molality, it is a ratio of mass of solute presenting 1 kilogram of solution. Right? So please see the differences, and there are different examples you can solve with respect to the different types of problems given in the textbooks. Right? So the remaining things regarding different types of concentration of solutions we will see in the next class. Okay. Thank you. If you have any problem related to this, you can message me in the group as well as personally. Right. So in the next class, I'll just revise and then go for the next concept. Right. Okay. So all the best. Thank you.